Hello everyone, this is Bandgar SS, working as a assistant professor at Department of Physics, KTHM College, Nasa. Today we have going to discuss M.Sc second year semester 3, paper 3, experimental technique in physics first. Today we have going to discuss the topic of signal analysis and sensors, and we have to cover up the subtopic of measurement and error. So starting with measurement. Starting with what is the measurement, what is the definition of measurement, and what is the need of measure. So starting with a measurement. So measurement, it is nothing but a natural phenomena. It is converted into a quantity form. That is known as the measure. So number of describing natural phenomena like as the pressure, temperature, force, displacement, light, etc. into a quantitative terms, that is the numeric form, is known as a measure. So physical parameter converted into a numeric form, that is known as the measure. So measurement, it is the nothing but the numerical quantization of a attribute of quantity. It is measure unknown parameters of physical quantity. So what is the unknown parameter? Like as a chemical, electrical, physical. So these are the unknown parameter of physical quantity to be measured. Now next one is the what is the need, what is the aim of measurement. So first one is the to represent the magnitude of attribute of natural phenomena. So we have to represent the magnitude of that natural quantity. Second one, to record continuous measurement, a recording of many natural quantities. So these are the physical quantities varying with a time. So that is the continuous signal. So we have to record a continuous measurement and recording of a many natural quantity. Third one is the to measure and record physical, mechanical, chemical, electrical parameter of the physical quantity. So we have to measure the different parameters of a physical quantity. So we have to take the both measurement and record. So these are the three need or aim of a measurement system. Now next one concept is the result of measurement. So every measurement is a not perfect because of there is some errors generated due to some factors. So no result of measurement can be made with perfect accuracy and precision. So each and every measurement result is not perfect, not accurate, or not precise. So we have to require some error detection and correction techniques. So any result of measurement have error and uncertainty. So we have to require desired result, so that we have to require error or uncertainty detection and correction techniques. If you have to ignore the error or uncertainty, then desired result will not generate it. So when we measured any quantity, so never you get the perfect, accurate or precise or perfect. So that's time we have to require some error correction or detection technique. So you have to easily remove that error. If you have to ignore that error, if you will not get desired result. Now next concept is the error. So every measurement it generates the error. So we have to require to study of the error. So why it is generated, where it generated, and what is the source of it. So starting with what is the error. So starting with definition, the algebraic difference between the measured value and true value of a measurand is known as error. The error is usually expressed in percent of the full scale output. So every time error is denoted in a full scale, percentage of full scale output. The ratio of this error to the full-scale output is measure of the accuracy of the device. So full-scale output is gives the accuracy of the that measurement device or system. So you have to calculate accuracy. Then we have to know the how much error is generated in your output. So accuracy, their mathematical expression is the accuracy is equal to error. Error nothing but your observed value of a measurement system minus your standard output of the measurement system upon full scale output into 100. So you will get the full scale output accuracy of that device. Then you have to say, or you have to get the how much error or how much your output is accurate compared to the your standard value. Now these are the different errors and uncertainty sources. So we have to know every time a measurement system the error. So why it is generated? What is the source of error? Error we generated the with error out. So first one is the extreme vibration. So that is the measurement system has the some vibrations. Second one is the mechanical shocks. Third one is the misalignment of moving parts. Next one is the electrical leakage. Next one is the poor optics, friction, voltage fluctuation, continued high and low readings, excessive torque, irregular spring tension, cable noise, linearity, zero drift, sensitivity, arc changes. So these are the some sources of error. So some are inequivalent of balance arms, change in ambient temperature, environmental conditions, operating conditions, interference, improper adjustment, defective standards, faulty installation, arsenic contacts, electrostatic noise, parallax error, or temperature effect. So these are the various sources of error and uncertainties of a measurement system. Now next concept is the classification of error. So error is classified by how to generate the error in a measurement system output. So it is some classification of error. So it has some different types, or that is the classified. So basically error is classified by two ways. First one is the by calculations and second one is the by observations. So in by calculation has the three subtypes. First one is the intrinsic error, second one is the absolute error, third one is the relative error. And by observation it has the again three subtypes. First one is the experimental or gross error, second one is the random or uncertainty error, third one is the systematic and cumulative error. And this third subtype of by observation error is again it has the some three subtype. First one is the observational error, second one is the environmental error, and third one is the instrumental error. So this is the classification of error or different types of error. Now starting with a by calculation error. So first one is the intrinsic error. So that error observed when the instrument is under the reference condition is termed as the intrinsic error. So when your instrument is under any reference condition, that time is error is generated, that is the intrinsic error. Next one is the absolute error. So absolute error, it is nothing but as the difference is obtained by the subtracting the true value of the quantity from the observed. So absolute error is nothing but the subtract the observed value from the standard value, you will get the absolute error. Next one is the relative error. Relative error, it is nothing but the ratio of absolute error upon true value. So you have to know what is the absolute error. So that is the difference between the true value and observed value or standard value. And relative error, it's the ratio of absolute error upon true value. So That is the relative error. Now next one is the by observational error. The first one is the type is the experimental or gross error. So these are the manual errors in reading instruments or recording and calculating measurement result as a gross error. So it is the partly systematic or partly random. So it is the sometimes it as a systematic or sometimes it as a random. So generally these error occur during the experiments where the experimenter might read or record a value different from the actual probability due to poor sight. So by observer poor sight we have to get the some experimental or gross. So with human concepts types of error will be put, although they can be estimated or correct. So you can be easily estimate or you can easily detect or correct that error. So these types of error can be prohibited by the couple of actions. That type of error is not generated by the instrument. So take the careful reading as well as recording of information. Now next, taking the multiple readings by different objects. So we have to take the number of readings by using a different observer or object. A close agreement between a different readings ensure remove any losses. So we have to take the different reading or a close agreement between a different reading ensure the removal. Now second type of by observation error is a random or uncertainty error. The situation or disturbance which cause this error are known, hence they are termed as a random error. So random error, it is the randomly generated at the output. So that's why that is the called random or uncertainty error. So these occurs due to a group of small factors which fluctuate from one measurement to the another. When repeated measurement of the same quantity result in a different value is known as a random error. So when we take the repeated measurement and same quantity of result in different values are generated at the output, that is the known as the random error. So these error is generated by a unpredictable fluctuation in temperature, voltage supply, mechanical vibration of experimental setups, comma, random oscillations, comma, atmospheric condition, comma, frictions, spring hysteresis, or etc. So these are the some variable aspects affects that your output and generates the error. So these error may be reduced by the taking the average of large number of readings and various statistical tools like as arithmetic mean, range, dispersion, deviation, average deviation, standard deviation, and variance, and etc. So we have to use some statistical tools to easily remove that the random or uncertainty error. Now third type of observation error is the systematic and cultivated error. So these systematic error are relatively constant error, that is the not fluctuated or not stable. So that is the constant error occurring due to such effects sensitivity, zero drift, known as the non-linearity of a faulty equipment or faulty experiment design or techniques. So systematic error is the constant error due to some faulty instrument, faulty experiment techniques and designs. So their effects of sensitivity, zero drift, and non-linearity. So these error may be occur because of there is something wrong with instrument or its data handling system by a human. Second one is because of instrument is wrongly used by a experimenter or observer or operator. So Systematic error can be eliminated by use a statistical procedure based on a repetitive measure. Second one is the carried out under different conditions, different equipment, and carried out by new methods or techniques or designs. So systematic error is easily eliminated because of it is the constant error. So we have to use some statistical tools, different conditions, different equipment, different methods, techniques or designs. Now, systematic or cultivated error, it again has the three subtypes. First is the observational error, second one is the environmental error, third one is the instrumental error. So starting with a observational error, this error also known as the operational error or human or personal error. So that error, it is generated when the operator performing the experiment. Error is generated due to a improper adjustment, use of defective standards. Third one is the incorrect scale of marking or reading. Third one is the parallax error. Fifth one is the poor instrument operator trainings. Next one is the carelessness of lack of experiments or individual verification. So these are the some affection of a measurement system and due to generated error in a desired output. Now next one, this error can be easily eliminated by taking the number of readings with trained observers. Second one is the independent checks of the measured variables, the reading taken by the more observer or operator. Second subtype of systematic error is environmental error. This type of error are generated due to variation of external or surrounding condition to the measuring device. So here error generated due to a environmental condition. So these error generated due to a changes in environmental conditions. Instrument characteristics are the effects of changes temperature, humidity, wind, forces, barometric pressure, magnetic or electrostatic field, and etc. Next one is the Barnett effect of the wind cause errors on a weight of chemical balance. So there is the Barnett effect when wind are changes. So there is the chemical weighing of chemical balances are changes. Next one is the atmospheric interference, cable noise, electric machine noise. So these are the some error generation effects due to generates the error. So this error can be eliminated by isolation or frequency discrimination, use air conditioner, sealing certain component, and use magnetic shifts. Next one is the third subtype of a systematic error is instrumental error. So certain errors are inherent in the instrument system. This error is generated poor design, construction of the instrument, division of graduated scale, inequality of balance arm, irregular spring tension. Fourth one is the equipment calibration linearity, zero drift, and sensitivity. So these are the four parameters that affects or generates the error in a measurement system output. This error can be eliminated by selecting the suitable instrument for a given application, applying suitable correction after determining the amount of instrument error. Next one is the calibrating the instrument against a suitable standard. Fourth one is the statistical procedure based on a repetitive measurement which carried out under different conditions, different equipment, different methods and designs. So that is the instrumental error. Thank you.